Okay, we're going to be looking at limits at infinity. So what's going to happen as we go towards infinity? Well, infinity isn't, it's not a tangible number. I can't plug this in. However, I can imagine what's going to happen. So as x gets bigger, obviously x squared would get bigger. Well, what happens as the denominator gets bigger? 3 over 10, 3 over 100. What about as I add more zeros, right? The overall value becomes smaller. So this is tending towards 0. So this value here is actually going towards 0. So the answer is 4. You can think about it logically like that, or remember your asymptote rules. This is actually, this 3 over x squared has a larger value in the denominator for the degree. That means that the asymptote is at 0. So what's 4 minus 0? Well, it's 0. So here are your old rules for asymptotes mixed with these new limits. If you have x to the a power over x to the b, and the degree in the numerator is less, the limit is equal to 0. If you have the degree in the numerator bigger, the limit is infinity or negative infinity. And if there's a coefficient and they're the same, then we divide. Those are the exact same as our asymptote properties. So if we have this, right, we want to find the limit as x approaches infinity of f of x. Really, you can think about plugging in infinity. What's going to happen? Where's this going to go to? But we can look at where our asymptote is. Here, asymptote is larger in the denominator, right? So when that value in the denominator is larger, limit is equal to 0. For b, what's the limit as x approaches infinity for that function? They're the same, so the asymptote's at negative 2/3. That's where the limit is as well. And as x approaches infinity for that last function, here the degree is larger in the numerator. So if we look for the highest degree power of x and check the sign of infinity by substituting with large x value. So notice as x gets larger and larger and larger, this denominator stays positive. What about the numerator though? Well, this is just adding a 3, but this is going to become more negative. We're taking some value and we're cubing it. Some very large value, and then we're multiplying it by negative 2. That's going to be more negative. This limit is actually negative infinity because we're going to have a negative divided by a positive. So be careful. Think logically about that. So here are some example problems. So as we go to negative infinity here, well, if we have some negative values in here, this is just going to tend towards negative infinity. X to the x cubed minus 4x squared plus 5. Actually, if you remember your graphing rules way back from the first semester, this is an odd degree with a positive leading coefficient. This is going to look like that. So notice the y value goes down as the x value becomes more negative. Here, the degree in the numerator is larger. So when the degree in the numerator is larger, it's going to be infinity or positive infinity. And this is actually going to be positive infinity because if the numerator will always be positive and this denominator will be positive as well. Over here, same deal. Very similar question. Right, this is going to be tending towards infinity as well. And here, maybe we could factor it. But by just looking and seeing the denominator is larger than the denominator, I know this is equal to 0. And so that's it. So it kind of takes a little bit of thinking, a little bit of logic, a little bit of plugging in, playing around with. But definitely take your time as you go through these questions and remember your asymptote properties.